Okay, start recording. Okay, so we are almost done with the list. Okay, so we managed to cover up to rule 34. Today we do one more, rule 35, another techniques. Okay, and then after that will be applications. Okay, 35, separating variable. This is a very short one. 35, separating variables. Okay, you'll be given a differential equation dy dx in the form of f of x times g of y. So their relationship is a multiply divide. Okay, under these circumstances, you actually can gather all the y on the same side, gather all the x on the same side. So 1 over gy dy equals to fx dx. But the dy and dx cannot be written just like that. Individually, you have to attach together with the integration sign. So after that, you have some sort of gy, okay? Something on the left and something on the right. Okay, plus c. Okay, the plus c, usually we have a plus c on the after you do finish integration, isn't it? Over here, you will be uh, you will be you only substitute the plus c on either side. Okay, one side will do. Okay, now let's look at example. Okay, so from when we deal with implicit differentiation, we have dy dx equals to negative y over x. Okay, we managed to get these questions previously. Okay, let's see what we're going to have. What are we going to have here? So according to the form, we need to gather the x on the same side. You need to gather the y on the same side. Sorry, I wrote them wrongly. This one should be negative x over y. So over here, okay, I gather the y together, dy equals negative x dx. Okay, put the integration sign. So according to the integration, we have a y squared over 2, negative x squared over 2, plus c. As I say, you put the plus c on the same side, only on the one side. So multiply everything by 2. Okay, so you will see that we fulfill a circle equation. Okay, so this is actually how we actually do separating variable in order to get what we want. Okay, so over here there are many different differential equation that we have here. This is actually called differential equation. Okay, but this one is called separatable. Okay, this type is called separatable. Then and as you can see from here, the question, it can be appear as anything. Okay, it's not necessary in the nice exponential form ln poly 3 equal e. It can be it can take care, the question can ask for anything. Okay, so we will expect students to know how do you you know the formula for a b c d e, because this is section F. Okay, so let's look at the questions. Okay, you can see that, okay, we have some questions here, okay, that you can actually look at. Okay, they are all separatable. Okay, so you can see that all the y and x have together on this on one side. So the only challenges is whether you know how to separate them Okay, and with the initial condition given, okay, you will need to solve the plus c. Okay, then okay, with this, okay, 35 is just like that, nothing special here. Comes to application, trapezium rule. Okay, this is for under pure 2. Okay, so this is an approximation method. Okay, you can actually learn this as an extra. Then 37, you have a area by x. We can have a Cartesian form and the parametric form. Okay, area by y, volume by x. We have the Cartesian form or the parametric form. Okay, so we just apply the formula. Then something extra, this something extra also appear from the past year before. If I have a 2 power x, what should I do? So it's actually a reverse process of your differentiation. If I have a log base a, log base 2x, so we apply changing of base. Then after that, we actually have rule 28 previously. Okay, that lead us to this solution. Okay, and with this, okay, this is chapter 5 and 7. When you look at exercise 7, okay, so you are expected to know how to use all the formulas as well as understand the questions. Okay, usually they give you a situation, then you have to understand them accordingly. Okay, that's all for today. Okay, thank you very much. Stop recording.